Hi, everyone. Kevin Kline here with SolarWinds, and I'm so thankful you've carved out a half an hour of your time to spend it with Jeff and I to talk about select answers from DBA where users equal frustrated. And today, what we're going to be talking about is SQL statements, and how to make them better, and some of the exciting new capabilities we've added to the products that include and utilize generative AI. So with that, just a quick word about myself. Been in the industry for a long time, written a lot of books. The main thing I want you to know is how to get in touch with me. So I'm on Facebook, LinkedIn, Twitter, all of those things at K.E. Kline. And the other is kevin.kline@solarwinds.com. If you have any questions, I'd love to talk with you some further. Jeff.
Hi, Jeff Garbus. I'm the CEO of Soaring Data Solutions. I've got about 20 books in print, and I've been doing this for about 30 years, back to SQL 4.01, running on OS 2, if anybody remembers what any of those numbers or letters mean. Soaring Eagle does, basically, we're a database consulting and managed services company. Thank you, Kevin, for inviting me to come out and play. This is fun stuff for me.
Indeed. So what are we going to talk about today? Well, we're going to take you through what SolarWinds does in the database space and show you a few of our products in case you're not currently a user. Then we're going to talk about finding poorly performing SQL statements using just the native tools that are available to you. Now, our tools cover all the major relational database platforms, but today we're going to use SQL Server as our main use case and set of examples. But this works equally well for Oracle, Postgres, MySQL, MariaDB, and all the cloud versions, as well as the standard on-premise versions. So we'll show you how to do that natively, just in case you've never done any query tuning or that kind of research to find out what your poor performing queries are. Then we'll take you through using some of our products to find top SQL and what needs to be fixed, and how the products as they exist a few months ago would take you through that process and speed everything up. And then finally, we're going to show you a demo of AI Query Assist, which actually takes us leapfrogging us into the future, where the generative AI LLM suggests improvements and really, really speeds up that whole process enormously. Sound good?
All right, works for me.
Okay, so just in a nutshell, we have three main products that assist with database management and administration through monitoring. And if you are responsible for databases and you don't have a monitoring system, you're kind of breaking rule number one. You cannot know what abnormal is on your system if you don't know what normal is. And you can't fix a problem before your end users find out about them if you're not already monitoring to see if things are abnormal. And so it's extremely important to have a monitoring tool.
Yeah, if I can add, historically, DBAs have built their own performance monitoring tools. And I remember the first time I went into a shop and I said, I've got this great tool. I know you've built some of your own. And he said to me, Jeff, do you have any idea how much time and effort it takes me to keep this tool up to date? You guys do this for us. Man, it makes my life easier.
Definitely. What we're looking at here is three SolarWinds products. DPA's Database Performance Analyzer. That is our heterogeneous, broad-based database monitoring system. It can monitor over 30 different types of databases. When you look at all the different versions of, say, Azure SQL, we have AWS SQL in multiple different ways. Google has it as well as on premises. So when you add those up, it's quite a lot. And it approaches the whole monitoring, resource consumption, and troubleshooting process, starting with wake statistics, which is ideal. It's the best place to start. It's very easy to use. Developers and DBAs love it. The second one I want to tell you about is SQL Sentry. SQL Sentry is our deepest product for the Microsoft data platform. So in this particular case, what you want is you're a business critical stack on top of Microsoft. Your company makes or breaks its numbers based on whether you can tell exactly what is happening deep inside your Microsoft SQL Server databases or analysis services and what have you. And so this product goes deeper than any others, and it also goes broader too. For example, it gives you great visibility, amazing visibility into all of your SQL agent jobs. And if they're conflicting with any high resource consumption end users and things like that. And then finally, in the middle, we have our database observability product. It's our newest. It is SaaS first. So it runs entirely on the cloud. And although it can monitor on-premises SQL servers, it's intended primarily to monitor other cloud databases, as well as NoSQL databases like Cassandra and MongoDB. So those are our three products. The newest thing that we're working on, like everyone else in technology these days, is integrating AI, leveraging it so that it gives us maximum capabilities. So we can do things like speed up our time to identification of problems, MTTI, MTTR in terms of time to remediate those problems. So it is a force multiplier. It makes you much more powerful and much more capable. One of the most common use cases that we have had in our AI of previous years, we've had machine learning and anomaly detection. So one thing that I have enjoyed for the last few years is how beautifully the tools do a job of showing you what's different today than yesterday. Jeff, I'm pretty sure you've had that common question come up where your user says, everything was great yesterday. We're not doing anything different.
And what is the question that everybody asks? What changed?
What changed?
And they always say nothing.
Nothing.
But what this gives us the ability to do is go and find out what's going on when it changed. If the code has changed, we'll see that. If a resource became constricted, we'll see that. If somebody dropped an index or something became corrupt and is unusable, we'll see that. So.
We did deploy one little noob report that takes 30 minutes to run and keeps everybody else from getting anything done.
One of the think tanks came up with the number, specifically 80% of mean time to resolution with performance issues is identifying the root cause of the problem. And one of the things I love about your tools is that it almost eliminates that 80% of the time. It takes the whole war room and says, we don't need you anymore, because we don't have all the finger pointing going on. And instead we go, yes, this is where the bottleneck is. This is where the time is being spent. Just an enormous time saver.
Right, indeed. The next part is once we find whatever's performing poorly, we have to fix it. And that always takes years of experience and attention to detail to learn the different red flags and yellow flags and so forth. So what we're going to do now is we're going to take a moment and show you, just in case you've never done the query tuning side of things, we're going to show you what you get in the native tools. There's two ways to identify your top SQL statements in SQL Server natively in Management Studio, using the query store and using DMV queries. So let me show you that. So what we're looking at now is Management Studio. This is actually SQL Server Management Studio 2019. There are new releases of it since then, but this is a very common and popular release of the product. And when you're doing SQL troubleshooting, the first thing you need to do is you need to identify which of those queries are the most poorly performing, right? And so one of the ways that we can do that is to simply query the dynamic management views inside of SQL Server. If you're an Oracle person, you might know them as $V tables and $X tables. And SQL Server, they're DMVs. And when we query these, we get all kinds of information about the performance of internal operations of SQL Server. In this case, we're looking at query execution stats, as well as the query plan and the query text. I'm getting a lot of performance information, where the query is running, what its object ID is, and that sort of thing. How long it ran, how many times it's been run. And then in the order by statement down here, according to what I think the problem is, maybe CPU, duration, reads, writes, and so forth, I can issue an order by and just put all of this into the order that's most relevant to me. So when I execute this query, you can see here at the bottom, it tells me what my most resource consuming SQL statement is according to what I filtered on, which was average physical reads. If you look down here in the order by. So I'm going to see at the top, my average physical reads is this particular statement here. But you can go as far back as 2016 and you can use something called the query store. Now, it must be enabled and set up. But one thing that's neat about the query store is it keeps track of lots of things that you might not otherwise keep an eye on. For example, if you had a query that performed well and then stopped performing well, maybe a new index started to change in an index, started to make things behave differently. So we can just double click on these different options that we have here under Query Store, and we can see what queries are taking up the most time and energy. In this case, it's the query I used to look up what was most problematic in the top SQL. But here, when we look at the different other SQL statements, you'll also notice a dot here. If the dot appears multiple times, that tells you how many times it's been run in this time period, as well as if the color changes, then you know that it has a different execution plan. So that's what we wanted to show you at this stage, though, just how to access Query Store once you've turned it on, and also how to issue some SQL queries against the DMVs to see what the different performance metrics are for the queries. Now, having done that, let me switch us back to the slides. So Jeff, we just talked about how SSMS can help us with that, but we have tools that can make this so much easier. Why don't you tell us a little bit about DPA?
Why don't I tell you by showing you what it looks like? I can talk for an hour just about DPA, but I'm going to try to keep this down to about 3 minutes. What DPA allows you to do is across different types of database environments, and you can see several of them listed here. Now, when I get involved, most of what I do these days is performance and tuning related. So just looking at this first DPA screen, I can see that this is the busiest SQL server. So I'm going to start with the busiest SQL server because I looked at it a few minutes ago and it made it easy for me to spot an anomaly. How do I spot an anomaly? Really easily. I've got this big red R that says something changed.
The flashing light and siren there?
The lights and the sirens, yes, the flashing red lights in your rearview mirror. This being 5 days old, it's rearview mirror, but we're not being pulled over, fortunately. Every time I click on something, it does a drill down. So you saw from the list of servers, we went to the list of days, we spotted the anomaly, and now we've got the times of day. And I can tell again from the lights and sirens that the alarm hit at about 10. So when I click at 10 a.m., we can find out what the busiest queries were at 10 a.m. What's at the top? What's bubbled to the top is the query that's using the most resources. Now, keep in mind, this can be something that's running once and it's taking a long time, or it can be running, 10,000 times a second and taking 100 milliseconds. And when we tune that 100 milliseconds down to, 2 milliseconds, suddenly the system feels faster and we save on our Azure costs. And everybody calls and says, did you do something? I know I can't quantify, but things feel faster. And I have gotten those phone calls. But looking at the top query, I'm just hovering over this. I'm not clicking on anything yet. And it says we're data like, quote, percent. Well, most of us who've done any tuning realize that that means we're forcing a table scan. And so this is a problematic query. But when we're not getting this forest green color, it's telling us something else. And that is that I am likely resource constrained. The resources are being constrained by now are IO latch weight. But what the page IO latch is telling us is that the data is not getting into memory fast enough for us to get it back out. This can be a memory issue. This can be a disk issue. So we can slice and dice this. I'm going to show you 2 ways to get to this information. One is when I click on time slice, I can keep going to smaller and smaller time slices. I can get this down to the mere second if I want. And I can find out what the resource utilization was down to that usually second, but as often as it's gathering a particular metric.
So tell us a little bit more about the tuning advice it can give us.
Again, poking around, Kevin spotted this one earlier, and that is that this particular server had a lot of things going on. We could identify that on this home screen, by the way, by looking at all these red dots. As we see the red dots, we are seeing opportunities. And when we click on the server, we see that we have a tuning tab highlighted. The tuning tab gives us a lot of interesting information because it's gathering information and doing some analysis internally. So, what does this analysis look like? To start with, it's identified some specific indexes that will save us a lot of time. So, if I can take a 2 hour and 39-minute query and eliminate 2 hours and 38 minutes of that time, we're going to get some happy campers. How do we do that? Yeah. How do we do that? Add this index. Now, you don't just add indexes into your system without testing them. I have, but I always have permission. But there's a good chance that this query is going to, this index is going to have a major positive effect. 2 query origins. It means there's 2 different queries that are going to benefit from this one. We have a variety of query advisors, but we've identified, again, based on DPA, looking at DMVs and other tuning information, that specific queries should be addressed and how they should be addressed, as well as specific very busy tables. So we can click on a table and say, okay, 18 different queries are going to benefit from tuning. We have 5 index recommendations on that table. Wonder what they are. Let's go find out, add the indexes, and circle back. Adding indexes is probably your single safest query tuning approach because it fixes an underlying problem. Throwing memory, throwing CPU, throwing faster disk. Unless you've identified that you have that specific resource and that it's the bottleneck and it's not a query causing the bottleneck, it can be a very expensive way of resolving queries.
Very, very true. Well, let's flip back now to our slides. Thank you for showing DPA, and that you've just hit the tip of the iceberg, as you said. We could talk about that for quite a long time. Now we switched over to SQL Sentry here, and I want to show you a similar sort of feature as to what Jeff just showed in DPA. And it's very simple. We do keep track of the weights in the same way in SQL Sentry that we do in DPA. And so when we want to look at a particular performing set of SQL, it's very easy. All we have to do is go over here and click on Top SQL. You may also want to choose a specific time period to narrow it down. You may want to do some other things associated with filtering what you're looking at. But in general, in any way you spin the data of activity on your SQL server, you can check and see by application, by database, by user, and so forth, and narrow down that work. And here we have all of the database activity that is happening on this SQL server in terms of completed queries. And we can sort on any of these particular queries if we wish to. And this is where we get to the really good part. There's a new button here called AI Query Assist. When I click that, it will go off and think about things for a minute, like LLMs do, and then it will give me alternative, better performing SQL statements. But first, I do want to take one moment and show you the traditional way that we would need to do this, which is to use Plan Explorer or Management Studio to tune up our query. Okay, let me now take a moment and show you how to do this in Plan Explorer. So here we are looking at a query against the AdventureWorks database in Plan Explorer. And by the way, it integrates into Management Studio. So you can, on a right click, looking at an execution plan in Management Studio, open it here in Plan Explorer. And the first thing you will notice is that we have lots of pretty color coding. If you hover over any of the color coding, a tooltip will tell you why that color is significant. So a common example is that our indexes become stale because we're not keeping up with the index statistics and refreshing those. And that's what this shows us. If your estimated number of rows differ from your actual number of rows returned by the query by more than about 10%, then you know your statistics are out of date. In the same way, we can see here that this sort operation in red is one of our most expensive IO operations. We have the hash match join, which is also expensive. If we scroll down, we can see that we have index scans, all of which are expensive. If we look here, one of the things you can do, this is a more complex query, we can actually zoom in and zoom out and much more effectively see what is, if we notice over here, there's something red down there, right? So we can zoom in on it. Now we have a warning coming up here, missing indexes. We have a residual IO problem on the table scan over here. We have some other problems on the hash match. So it's spilled to TempDB in order to resolve that particular query. So this is really, really powerful. You have to learn a little bit about how to query tune in these circumstances when you're using these tools.
Not to mention what a hash match is and why you need to fix it and what a bookmark lookup is and all the rest
Exactly.
of
Or
it.
you look up all those things. So
That's why we have a class out.
that's right. That's right. And there will always be classes on it for people who really want mastery. The good news, though, is that you don't have to know everything there is to be effective at turning a poor query into a pretty good query. And there's just a handful of really bad operations that can happen in your SQL statement. There's many that are basically negligible. They don't really add any work to what the SQL statement is doing behind the scenes. So as Jeff mentioned, you want to look for bookmark lookups, key lookups, row ID lookups. If you have spools and spills, if you have more than one sort, that's usually an order by statement, but you don't need more than one typically in a query, and sorts have to be resolved in TempDB. So it's problematic. I mentioned high physical reads and estimated versus actual record counts. And Jeff, you have a blog that you post a lot of these kinds of useful queries on. Where can we find that?
Sure. I can bring it right up for you if you like. This is a blog that I use to keep all the code that I don't want to have to rewrite every time I go to a new place to do performance and tuning. You're all welcome to subscribe and steal the code. I have code in here to do things like identify missing indexes, find duplicate indexes, find unused indexes, all kinds of fun stuff in here. For those of you who have not used the DMVs, go ahead and take a look at some of my code. I've got some code in here that finds missing indexes based on what's in the DMV.
Absolutely. And so any further thoughts on query tuning and so forth before we move into looking at the AI Query Assist?
Yeah, I just want to make a couple of comments about these red flags. Some of them are really easy to deal with. Lookups of all sorts can usually be eliminated by simply adding a couple of columns to an include list. Scans, sometimes you don't understand why a scan is there, but an index scan might be because you don't have the columns correctly sequenced in an index. So, taking a little bit of time to learn what these plan operators mean can save you a lot of time and energy.
Absolutely. Very, very true. And we cover what all of those weight statistics and so forth mean in the product. So I encourage you to take a look at DPA's help, as well as that in SQL Sentry that explains many of those things to you.
Oh, you have great help in there. And in fact, I probably should have pointed out during the DPA demo that if you don't know what a page IO latch weight is, if you click on it, you get a nice little presentation along with live links out to Google and such.
Exactly. So let's talk about AI Query Assist. I showed you in SQL Sentry that there was a little sparkly icon in there, AI Query Assist. You can click that button, and what it does is it takes and creates a package of information and sends it to the LLM, and that includes things like the table definitions, the execution plan, the SQL statement itself. It will produce a better performing alternative which you absolutely have to test before you put into production. But it will explain to you what considerations it made to make that choice, as well as explaining why it chose from multiple options a specific choice.
This is almost like having an AI tutor slash mentor showing you why your SQL could be better than it was.
Absolutely. And I would encourage you to use it aspirationally in the sense of, I'm going to use this to get better. Don't trust everything it tells you. Make sure you use products like Plan Explorer and Management Studio to test and verify that it does improve performance without causing any negative side effects, maybe increased locking, for example. But here's an example. We have a very simple query from the actually, in this case, it's in the AdventureWorks database on sales order data. And then the better performing alternative is on the right. And you can see that we have some differences happening here. We've got a cast statement, we have a join, we have a group by. So why did it make those choices? Well, we can look at the thinking tab as well to see what different thoughts it has. And we can look at the explanation tab to see all of the different things it described to us. So for example, in the before version, there was a cursor. We can get rid of that cursor. Cursors in SQL Server consume more space. They consume more resources, basically, I should say. So it's not a flashy demo. I wanted to show you what the results were. And then also, once you are ready, you can simply click the copy button here and put that into your test suite and make sure that it is operating in the way you would like to. To wrap up, troubleshooting is hard. Detecting problems is difficult. And if you're not doing that already in your database environment, you're doing yourself a big disservice. The benefits are worth the value, worth the expense. They can make your shop run so much faster. You keep your databases running smoothly. And one of the biggest challenges that we often have is that we're not sure what to do once the problem is detected. And so now with AI Query Assist, even if you're not a great SQL query tuner, you can become a good one quickly using that feature. So also there is a QR code here if you'd like to see the newest white paper that I was author of about optimizing database performance. I'd love for you to download that. We have dozens more. And as we end in the final stretch, Jeff, I'm going to pass it over to you. Why don't you wrap up for us?
Sure, thanks. Just as far as the performance and tuning goes, I'd like to add that tuning is it's an ongoing operation. You do need to be proactive about it, and having a tool makes it really easy. I've heard it said that the best DBAs and administrators are the ones that you don't know are there because nothing ever goes wrong. And there's both truth and falsehood to that. The truth is that, yes, everybody's happy, but the falsehood is that they don't realize how much work you're doing behind the scenes. One of the great things about these tools is you can see before and after effects of all the changes that you make. So, once a month, you can just send your boss a little graph and go, you know what? This is where we are today. You're welcome. And just keep sitting in your corner if that's what you want to do, or communicate using effective documentation that you don't have to create by yourself in order to get there. This is a slide on who we are. We've been in business as Soaring Equal for a long time. We do mostly database managed services, but a lot of database related things. We do a lot of performance and tuning, high availability, scalability, uptime. Well, our contact information is here. I'd also like to offer for anybody who wants to download something like DPA, I offer an hour of this is what this is showing you in your system. So use me. An hour of my time is yours. Just reach out and ask.
So we'll stick around for a few more minutes to answer remaining questions in the queue. And with that, I'm so grateful for your time. I hope you'll take a moment and download these products, give them a try, inquire with further questions to me or generally to your SolarWinds contact. And with that, thank you so much.
Thanks for inviting me, Ken.